Hello everyone, this is Charlie from the Bloomingdale Public Library, and welcome to Introduction to Coding with Scratch. What is Scratch? Scratch is a high-level programming language where code is created by piecing code blocks together like a puzzle. It is designed to help people learn and get excited about computer coding. The website says ages 8 to 16, but my first experience with it was while trying to learn how to create and program circuits with a Raspberry Pi. And when your options are Scratch or Python, I thought Scratch was a pretty helpful option so I could focus more on the circuits and less on the code. So when you hear the words high level in reference to a programming language, that's what you want when you're just getting started, because a high level programming language usually sits on top of other lower level languages, and it's a little more easy for a human to read versus a computer or a machine. So low-level programming languages would be something like assembly or machine code, which is just ones and zeros. And I have worked with assembly before, and while not terribly difficult, you have to adopt a completely new way of thinking of even simple things like addition. So Scratch is available for free. You can go ahead and use it on their website at scratch.mit.edu, or you can download it from the /download page. I'm going to be using the downloaded version today, but if you use the online version, you can save to their cloud, or even look at other people's programs and comment and like, or share your own stuff too. So there's some community involved, but like I said, I'll be using the downloaded version today. So Scratch was originally developed by the MIT Media Lab, but it is now supported by the nonprofit called the Scratch Foundation. So with that, let's go ahead and look at the website. So we'll go to scratch.mit.edu. And that'll take you to a page like this. And if you wanted to get started, all you got to do is click Start Creating. And like I said, at the top right is where you can join Scratch and sign in. So now I'm going to close that and open up the downloaded version. And as you can see, it looks pretty much the same. So over on the top here, you can change the language if you like. Under File, it's just a matter of saving and loading. In editing, they give you something called Turbo Mode if things start to slow down, which they shouldn't for us today. Worth noting are the tutorials as well. If I go ahead and click on that, you can see there's a whole lot here, and I recommend having a look at that when you're done with this class. Go back. So on the left side is where we can see our code blocks, and they're color-coded. So you can either scroll through it, or you can just click on the colors on the left here. Oops. Of course, my recording software gets in the way again. So if you notice at the top, there's also a couple tabs here, where costumes are basically frames for animating, and there's sounds as well. We're not going to be looking at that too extensively, so we'll go back to the code. On the far right here, we have the stage, which is where you will see our programming take shape. Then below that is where you can add a stage, which will add a backdrop rather to the stage, which is just a background. And where we can also add sprites too, so there'll be more things on the stage to interact with each other. Every sprite or backdrop can also have its own code, and that's why you see a little kind of watermark here with the cat there to let you know that you're programming on the cat. If we were to go ahead and add a sprite real quick, you can see there's a whole bunch included for you. We'll go ahead and choose a bear. You see once I'm selecting the bear, we see the bear watermark at the top right. Go back to the cat, you see the cat again. If I wanted to add a backdrop, and we see a picture of the Arctic backdrop in the upper right corner. This middle area is where all our code will be going, and we'll have a look at that next. And using that is just going to be a matter of dragging and dropping code from the left to the right. When first learning any programming language, whether it's from a teacher, a book, or an online tutorial, it's tradition to start with what is known as the Hello World program. And what that is a typically short program that's purpose is just to display the words "Hello World" on the screen. So I'm not one to break from tradition, so we'll go ahead and do that. The kind of unusual thing about this program is, for most programming languages, doing input and output is a little bit more of an advanced topic. It might require a little bit extra knowledge or extra code, and this is no different in Scratch. So that is where I would typically start with a blank stage. In this case, we're going to be starting with the cat on there because I need the cat to show output. So when you first get going, you'll probably have a screen that looks like this, where there's no watermark in the upper right corner. That's actually the blank backdrop. That's, that would be here, but we can't see it. So we want to make sure to select the sprite. And you'll notice when I do, we get a couple of extra code block options. So from these, let's go ahead and find something that looks good. Here we go. Say hello. And to use this bit of code, all you gotta do is click and drag from the left onto the workspace or code space if you prefer. So I'm gonna go ahead and click where it says hello and type in "Hello World." That's all you need to do to set a value. And now when I click on this little bit of code, you see it says "Hello World" over on the stage here. Now that's nice if you have access to the code, but your typical user won't. So I'm going to go ahead. Up here is where you can choose to go and stop. I'm going to click the stop button here. And what your user is going to be looking at when I click the full screen control button here is this. And you'll notice there's no code for our user to click on, and you don't want your user accessing your code like that anyway. So I'm going to go ahead and minimize that. And you may have noticed that we did still have access to the flag. And so if I go down to the control section, oh, actually it's an event. So we have when the flag is clicked. And I like that as a starting point for pretty much any program that we're going to do here in Scratch. So now, go ahead and click on the code. It says "Hello World." We have access to the green flag up here as well. If I click on that, "Hello World." And if I go back to the full screen, again, we have access to the screen flag here. Click on that, "Hello World." And that's great. And that is our basic Hello World program in Scratch. Before we get going learning more of the language, I'd like to discuss a bit more about how the code blocks work. So, as I've already shown, to make some code execute on the stage, all you gotta do is click on it. In order to take code apart, all you gotta do is click and drag. And just remember, code comes apart from the bottom up and from the inside out. So let's say I wanted to try some new code here. All I gotta do is slip it in there. And there we go. So even though we've got "Hello World" still sitting around here, it can go ahead and do that and it won't execute because it's not a part of the code that I'm clicking on. I can go ahead and click on it and it will still execute though. So we can have a whole bunch of functional pieces on the space at one time, but only what I click on will actually work. So something else worth noting, and it'll be a little more transparent if I have things run a little bit longer. So we'll have them run forever. Now you'll notice I have two code blocks here that will execute when I click on the flag. And when I do that, sure enough, they both function. You'll notice that each code block has a yellow outline around it. That's how you know what code is running at any given time, is it'll have that highlight around it. So if I go ahead, click on the stop button, you'll notice they both stop. If I click on just a single piece of code, it doesn't matter that they both have the same trigger. I only clicked on one piece, so only one is running at that time. Again, if I wanted to take this apart, you can click on the bottom piece or the inside piece. Nothing to it. If you want to duplicate some code, it works the same way. If I right click on the forever piece, click duplicate, everything from the forever piece down and inside is duplicated. If you wanted to delete something, you can go ahead and right click and delete, and you'll notice it deletes everything inside the block as well. Just go like that. Or you can go ahead and click and drag and yank it off the workspace and delete things that way. So if we scroll down a bit, you'll notice we've been putting pieces together right now with this little three-edged kind of little tooth there. As we scroll down, we've got some other shapes that will fit into this oval spot. So anywhere you have an oval spot is a piece of code that evaluates to a number or a string, which is another way of saying text in programming language. So if I go ahead and click and drag, it fits right in just like that. And if you have trouble getting a piece in, try focusing on the upper left corner of the piece that you're trying to insert. So you see we also have one more shape, and that is a Boolean expression. Boolean expressions are expressions that evaluate to true or false instead of a number or a word. And those will go into conditional statements, which we'll also cover a little bit later. And they look like that. So again, find the right shape. You can go ahead and plug it in. And you can even nest them as well. So even though pieces fit, not every bit of code will work, because as you'll see, a lot of these are math operators, and if you were to have a variable that doesn't work that way, like, again, a bunch of words, you're basically going to get locked up, or if you try to type something in, it won't even let you. But we'll cover that next. Next, I want to talk about variables. Variables are basically containers for holding data, and programming is mostly about manipulating and doing things with variables. So if we scroll down to the bottom where it says variables, it's marked with the dark orange color. We start off by default with a variable called myVariable, and there's a couple others that are there by default that we'll cover in just a bit. If you want to know what value is in a variable, all you got to do is left click on it, and it's set to 0 by default. I'm going to go ahead and delete that variable by right clicking and selecting the delete variable, and I'm going to click on make a variable to create one of our own. So every variable has a type, and in Scratch that is going to be either a string, which is text, or a number. In Scratch, we don't have to determine what kind of variable we have. Scratch will look at it by value and figure out on its own what to do with it. So I am going to name our variable var1, and we have another selection to make here, whether this is going to be seen by all the sprites or just this one. And there's reasons why you'd want to have a variable hidden to other sprites. But to show you what that looks like, we'll start with for all sprites. Click OK. You'll notice over on the left, we see our var1. I'm going to go ahead and click on backdrops, and we still have access to var1. We'll click on sprite 1, make another variable. We'll call this one var2. Oops. And this one we'll make for this sprite only. Click OK. Sure enough, we see var2 over on the left. But if I click on the backdrop here, you see we do not have access to it. So if you have a variable that's gone missing, you might have accidentally clicked this sprite only circle. And in programming language, these are referred to as global and local variables. So now that we have our variables here, you'll see that there's a checkbox on the left side here. And what that does is make the value appear on the stage, which is pretty helpful for troubleshooting. If some variable takes on a value that you weren't expecting, you can go through your program and see where the variable gets that value. but usually you probably don't want to have that on the stage when your user is using it. So you uncheck those and it takes it off of the stage. So some other variables that are here by default, you see username, timer, loudness. You see mouse values, so this will determine the X position and Y position of your mouse pointer. And another fairly useful one here is answer. So this is how you would get input. So where it says ask, and you could put in whatever, and you'll get a box. In fact, why don't I just bring it up here? So ask, what's your name? If I click on that, we actually get a box for putting an input. And that input is going to be stored in answer, where we can do some other things with it. I'm going to put that aside for now. So that's variables. Next we'll have a look at operators, which is how we'd go about manipulating them. So in looking at operators, operators are basically how we go about manipulating our variables. And which operators you use is determined by the type of the variable. And like I said before, we don't actually list the type explicitly. Scratch will figure that out on its own. And depending on how you go about things, an operator won't work. So our first operator, it's actually not listed as one, but that is the assignment operator, and that's just set and then the variable. You click on the drop-down menu to choose which variable you want to set, and then you choose a value. So let's set var1 to 5. And then we've got our second variable here. Let's set var2 to 3. And now if we want to go ahead and do something with these two variables, let's say just add them together. We'll click on this operator block. It slips right in there like that. And we'll go ahead and put in var1 and var2. And it's going to set var1 to the value of var1 plus 2, basically overriding what's in var1. So we'll make a third variable. Make a variable called var3. Okay. And now from the drop down, we'll choose var3. And then we'll use our little output code here to say, oh, let's go ahead and drag this over here, var3. Uncheck, click, and sure enough, he says 8, just as you'd expect. So, like I was saying, what your operators do depends on the variable type. So if I were to say set var2 to hello, now when I click on the flag, I get 5. So basically, strings are set to 0 when you're doing arithmetic. Let's say I were to pull var2 out here and just try to type in a string value. I don't know if you can hear my keyboard or not, but I'm trying to type in hello and nothing happens. So if you try to explicitly do addition with a string, it won't let you. But if you use a variable that just happens to have a string value in it, it just will evaluate the string to 0 and try to carry out the operation anyway. So the opposite is not true. If you try to do a string operator with a number, Scratch will basically turn that number into a string and perform the operation that way. So let's go ahead, take all that out. Let's do join apple banana. So when I go ahead and click this, it'll give us what happens when you join apple banana, and sure enough, apple banana. Now let's say I were going to set instead of apple, put in var1. And var1 right now is a number. But if I click the flag here, you see it'll turn that 5 into a string value and then add the two strings together. So something to be aware of when you're working with strings and numbers. So you'll notice a couple other operators over here. with angled sides, those operators are called Boolean operators. And whereas these oval-shaped operators will evaluate to either a number or a string, these angled ones will evaluate to a Boolean value, which can be true or false. We don't actually have any Boolean variables in Scratch, but that's what it does. And we'll have a look at that when we look at conditional code blocks. So let's look at conditional statements. A conditional statement will basically execute a block of code dependent on whether a Boolean expression evaluates to true or false. So our conditional statements are in the control group, kind of a less dark orange, still kind of a darkish orange though. We have two kinds that we're going to look at today. We have the if statements, and then later we'll look at the repeat until. So for our if statement, let's go ahead and drag it over here. You can tell it's a conditional statement because it has the hexagon placeholder. So let's go ahead and stick one of these in here. We'll use the equals expression. Make a little spot here so we can set our variable first. And then depending on what happens here, we'll say something. So let's go ahead and see if var1 equals 50. And if it does, we'll go ahead and say equal. Now var1 is set to 5, so our cat probably shouldn't say anything. And when I hit the flag, sure enough, he stays silent. If I were to change this to 5, now this is true, and he should go ahead and tell us that it's equal. Perfect. So that's how we use a conditional statement. Now, it's not very helpful when nothing happens. So sometimes you want to do something when an expression evaluates to true, and something else if it's false. And that's when we use the if then else statement. So I'm going to go ahead, yank this out, and stick in the if then else. So we'll go ahead and set this to 50 again. So if var1 equals 50, we'll say equal. Otherwise, not equal. Go ahead and click the flag. Not equal, just as we'd expect. So the nice thing about the if then else is you can also nest them. So we'll go ahead and stick this if then else inside the other if then else. And now we can go ahead and test a little more specifically. In fact, let's go ahead and get the less than expression. And if it's less than 50, it'll say less. Otherwise, we'll say greater. Go ahead and clear that. Execute the code. And sure enough, it is not equal, so we go into the else box, and when we look at this, this evaluates to true, and sure enough, he says less. Let's say we were to check for 500 instead. It'll still be less. How about 3? Not thinking. So now, clear that, execute the code, and we actually make it all the way in to the greater block of code. So that is the if then else. The next topic I would like to discuss is loops, and we'll be covering two kinds of loops today, the for loop and the while loop. The for loop will execute a certain number of times, while the while loop will execute until a certain condition is true. So we're going to use the for loop to count to 10. In Scratch, they don't use the word for, they use repeat, and that's fine. And just so we're counting slow enough for us to see, I'm going to grab the say for 2 seconds block. We'll reduce it to 1. For counting, we'll use var1. So I'm going to go ahead and make sure it's set to 0 before the loop starts. In programming language, that's called initializing your variable, when you set your variable to a certain value at the beginning. And then all the way at the bottom here, I'm going to use the change by 1 block to change our variables. So with that all set up, we'll go ahead and click on the green flag. Oh, we're still saying hello. So we'll stop that, plug in var1 there, and there we go. So you see he started at 0, and he's probably going to only go up to 9. And that's fine. A lot of people that are intimidated by programming say they're not good at math. Most of the math involved with programming is actually adding by 1. So knowing when to add your 1 will change how your loops work in this case. So now when I flip the 2 statements, hit the flag, we'll now count from 1 to 10 instead of 0 to 9. So that is your basic for loop. And again, in Scratch they use the word repeat. So now let's have a look at the while loop. In the while loop in Scratch is also a little different. It says repeat until. So repeat until, and it wants a condition. Let's go ahead and try to make a guessing game out of this. So we'll guess a number between 1 and 10, and we'll get out of the loop when you get it right. So we'll set our magic number to 5, and we'll use var1 to store our answers in. And because we're guessing, we're actually going to need to take input. And the input block is the ask block here. So we'll go ahead and type in guess a number between 1 and 10. I've got an extra space in there. There we go. And so if we guess the number correctly, we'll get out. Otherwise, we're going to keep getting asked. So let's go ahead and grab our say block here. So we get it right. Correct. Otherwise, we're going to just get that question over and over again. Let me try to clear this out of the way here. So as I was saying before, when you ask the question of the user, it gets stored in this variable answer here. So we need to store that into our var1. Okay. So we go ahead, we ask what our number is, we set it to var1, and if var1 equals 5, we get correct. Otherwise, we keep going through the loop. In actuality, we probably could have just skipped this step here and put answer in the repeat clause, but I wanted to show how to set input to a variable. So let's go ahead and see if this guy works. Go. Guess a number between 1 and 10. Let's say 3. Nope. Say 1. Say 8. If I go ahead and say 5. Correct. And we're out of the loop. So that is the for and the while loops. We're coming up on the 30-minute mark, so we've got time for one more topic, and that topic is going to be motion. The motion code blocks are at the top of the list, and they are blue. If you don't see them, it might be because you have a backdrop selected. You see when I have a backdrop selected, we have a little message that says no motion blocks. That's because backdrops don't move. So make sure you have a sprite selected. And we have our motion blocks back. I'm going to let you look at most of these on your own. But you'll see most of them deal with changing these three variables, which is the X position, the Y position, and direction. So the X is where in the stage the character is with regards to left and right. The Y position is with regards to up and down. And his direction is basically what direction he's rotated in. So he's set to 90 by default. If you change it at all, he looks in a different direction. So I want to put everything together that we learned today and create an animation. So we're going to focus on walking back and forth. So to walk back and forth, you would want to change the X value. So I'll bring change X by 10. That's, I think, pixels. When I click on the code here, you see he starts walking along. To create an animation, we're probably going to want to use a loop. And for right now, let's use a forever loop. So the forever loop is basically a while loop that always evaluates to false. So it's going to keep on going until something yanks it out, and we're not going to learn about any of that today. So now, when I click on the code and we're changing X by 10 forever, you see he just keeps going until he runs off the side of the stage. So let's use some conditional statements to keep him on the stage. So you see the X value where he kind of went off is 272. So let's have it where if he goes over 270, he changes directions. So we'll change his X by -10 instead. At the same time, he's going to fly off the screen to the left side if he keeps going. So let's create two conditional statements, one keeping him from going off to the right, one from the left. So let's go ahead and grab our statements here. So if he goes over 270, we're going to turn him around with a -10. If he goes below -270, we're going to set him to +10. We're going to save his speed in a variable. We're going to call that X velocity. And so that's basically just going to be either positive or -10 depending on which direction he's going. So we're going to start with it set at 10. This is just initializing our variable. Make sure it's set to what we want. Again, if we go over 270 or below -270, we want to change the directions, and we're looking at the X position. So let's stick X position in there. If we go X position over 270 or X position below -270. And because we're storing the velocity in a variable now, we want to be changing X by the X velocity and not by 10 anymore. And in these conditional statements is where we're going to set the velocity, either positive or negative. So again, if we're going off the side, that's when we want to set it to negative. And if we're going off to the left, that's when we want to make it positive. And I apologize if that was kind of quick. But if we go ahead and play things now, you'll see he goes back and forth. So that's an example of putting together all of these ideas into a single code block in order to execute an animation. And it's nothing special, but I think it's still pretty effective at showing at how lots of little bits of code can actually make something interesting happen on the screen. So from here, I'd recommend having a look at the built-in tutorials. Some of the topics we didn't cover include handling events or sounds or the sensing code. So that would be a couple steps you can look at going forward. So I hope you learned something. I hope I piqued your interest. I thank you for checking in with me today, and I hope you have a good day.